Hello everyone. In this video I'm going to introduce you to this GitHub repo called shared sceptre template, which has a lot of confirmation templates written in Jinja 2, which should be consumed by sceptre. But before we go to that, we will review on how a traditional sceptre template would look like. So in sceptre, this is a tool to deploy CloudFormation templates. So basically, the standard template written for sceptre is just a standard CloudFormation template that looks like this. It has this syntax. This is written in the YAML format instead of JSON format. So it has description, is AWS template formation, and then resources. Resources is the minimum component that you need to have in any CloudFormation template. Although you can also have parameters and outputs. This one, just for the sake of it, only has resources, no outputs at all. So in this template, we're going to have VPC, route table, Internet Gateway, association between the route table and the Internet Gateway and the VPC, then network ACL, also subnet, and then association between network ACL to the subnet, and also another association between route table and the subnet. And in this template, all the values like this one are hard-coded into the template. So we're not going to parameterize this template just yet. We just use a very simple CloudFormation template to show you how standard CloudFormation template is deployed by a sceptre. So let's hit it. We're going to deploy this template using this command. So this command will invoke this script, which is this, and then it's going to assume an IAM role in this account called Harris demo. It's going to actually deploy it instead of just testing if it can be deployed. So setting to dry run to false, and then the action is deploy. The alternative for action is destroy, so we can either deploy the CloudFormation template or destroy the existing stack from AWS. And the item represents the directory or the file under sceptre config. So in this case, I'm going to deploy everything under this directory called demo01. You can also target specific YAML like this VPC YAML, which means I need to change this item from demo01a to demo01a/VPC YAML like this. But yeah, to make it consistent with other directories, I'm going to put just the directory name into item. So let's start it, and we're going to monitor the progress in the AWS console for it. So this is the AWS account for deployment. This account, the account ID is 7477502199604. It's the alias is Harris demo. As you can see, as the sceptre works, we can see the progress is creating all these resources within the stack. So a couple of resources are created already. We should be able to see the VPC is created. So that's the tag name for the VPC. It was retrieved from here, and then the IP address is 10.254.0.0/20, which was hard coded in the template like that, to 10.254.0.0/20, and then yeah, it should have route tables. Here you go, the route tables. There's route table for public, and then route table for private A and private B. And then these route tables should be associated with the subnets. Here you can see the association are there. There should be Internet Gateway, yeah. And then route table and network ACL. So network ACL is here. There you go, we have the network ACL. Now this is wrong association, but yeah, we can fix that later. I just wanted to show you that this is how the template is deployed using Sceptre. So as you can see, the CloudFormation for this one was named like this. This was automatically generated by Sceptre. So the first part, this VPC demo, was taken from the config YAML under /config under sceptre config. So this one makes up the first part of the CloudFormation template. This one. This was taken from the directory name. This one. And the last part, VPC, was taken from the YAML file name. This one, of the config, not the template, of the config. So that's a good thing about Sceptre. We don't need to worry about picking up the CloudFormation stack name for it. Just put the file name, and then Sceptre will take care of putting the CloudFormation stack name for it. So that's the very basic format of CloudFormation template with Sceptre. We can also enhance the template to have parameters. For example, we want to use the same template to deploy another VPC, probably in another account or another region, but this time we want to have different side of range for the VPC. So I have copied that VPC A YAML to VPC B YAML. I put a parameter. The parameter is called VPC side of block, and it's going to be referenced by the side of block section of the VPC creation. So this reference this. The default value, if nothing is specified, is 10.253.0.0/20. So if the template is invoked as it is, without providing a value for this parameter, it's going to deploy a VPC with side of block 10.253.0.0/20. So for this one, we're going to use that template with this demo01b directory. The file name is still the same, VPC YAML. As you can see, the template for this config is using VPC B YAML, and is overriding the side of block for the VPC to 10.254.30.0/20 instead of 10.253.0.0/20. First, I want to delete the previous stack. It shouldn't take long. Okay, the previous stack has been deleted. Let's refresh this. Yeah, it's gone. All the network ACL subnets route tables should be cleared. Yeah, no VPC, nothing. And we're going to deploy demo01b with this command. So it's exactly the same command, same script, same target account, dry run false. Action is, sorry, not destroy, but deploy. The action is deploy. Item is demo01b. Okay, let's deploy. So we should have a VPC with side of block of 10.254.32.0/20 instead of 10.253.0.0/20. Let's have a look at the VPC creation. Yeah, there we go. We have 10.254.30.0/20, which is the one defined in this demo01b/VPC YAML config. So just like the previous stack, it will also try to deploy all these resources: VPC, route table, Internet Gateway, association between route table and VPC, Internet Gateway and VPC, then network ACL, subnets and then associate the subnets to the corresponding network ACL and also route table, and then should be done. Yeah, that's the only difference between demo 01A and demo 01B. It's the CIDR block of the VPC. Subnet will be automatically calculated by AWS using these functions in here. So it's utilizing the call of select CIDR and get attribute. So this will return the CIDR block of the VPC. This will generate a list of CIDR range from the VP CIDR block. Each will have a /24, so 8 means 32 minus 8. That means it will generate a /24 CIDR block, and it will pick the first of 4 of the first generated CIDR block. So that means it's going to create, for the first one is 10.254.0/24, which will be assigned to public A. This one, yeah, 10.254.32.0. Actually, yeah, second one is 33.0/24, which is public B. Then so on, and then private A is 34.0/24. Private B is 10.254.35.0/24. So that is how we deploy a standard cloud messaging template with Sceptre. Now I'm going to delete this one before we continue with the Gen2 version of the template. So as you can see in the static template like this, all the resources are just thrown into the template. With the shared template that I have prepared in GitHub, it will look like this. So there will be a config that utilize one template, but that template only provides one or two type of resources. So for example, in this one, it will allow you to create VPC only, and probably another resource which is called VPC CIDR block to help you creating the IPv6 CIDR block of it. But yeah, in this config, I'm going to mimic the generated template of demo 01. So maybe I should just leave one demo 01 available, so we can compare to demo 02. Yeah, so in each of the shared Sceptre template, it allows you to deploy multiple instances of resources of the same type. So we can have, in this case, it's just only one VPC, but for example, in route table, we can have, in the demo 01, we deployed 2 route tables, so we can have 2 route tables here. That's the first route table for the public subnet, and this is the second route table for the private subnet for availability zone A, and the third one is another route table for private subnet for the availability zone B. So that's the concept. So instead of throwing everything in one big file, it allows you to separate the resources and focus on the configuration of each resource, so you can fine-tune each resource to the best setting possible, or probably the most secure possible that you want to achieve. And then the dependencies will be automatically linked using this directive from Sceptre using stack output. So let's deploy this demo 02A, this one, to the same account using this command. Script, account target, priority is false, action is deploy, item is demo 02A. Let's deploy it. and we can also monitor the status. So the first thing it creates is the VPC. Let's check the VPC. That's demo 1, this is demo 02A. It is already created. Now let's refresh this. What's created next? Internet Gateway, Network ACL at the same time, yeah. The Internet Gateway is being created. It is attached now since the association has been deployed. And then route tables. Sorry, network ACL first. Network ACL. This one. And then route table. Yeah, we can see some route tables for demo 02A are created. And last part is the subnet. So route table is created, and we should see the subnet for demo 02A. There we go. Some subnets are created. Yeah, it's done. So subnets are created, route table, network ACL, the gateway, and the VPC. Now let's have a look at the generated template. So you know, with Jinja2 template, it's written in Jinja2, which means CloudFormation does not recognize Jinja2. But when the Jinja2 is passed with the provided variables, it's passed by sceptre, it will produce an actual CloudFormation template. So even though the template will look like this, let me bring up EC2 VPC, EC2 VPC YAML J2, this one, yeah. And provided that the variables are defined like these, so these are all variables that will be passed together with the Jinja2 template, it will produce a nice CloudFormation template like this. And as you can see, it will automatically produce some outputs. And the outputs are not just the value, but it also produces the exports. You can check the outputs from here. So the key, the value, description, and exports. For those who don't use CDK, most of the time they only produce the outputs. If they do, they will produce output as key, value, and that's it. A lot of people don't even bother with the description, and most of the time they don't even create exports. If you use AWS CDK relies heavily on exports, which means you can then import it to another stack using that intrinsic function called import value. Like this one, there should be a template. There should be import value somewhere over here. There you go. That's another intrinsic value. So this is how you import the value of the export produced in this stack. That was the export, and that's the value. So if you inspect other stack also has the standard CloudFormation template, and they also have outputs. So what are these outputs? These outputs are standard outputs that can be produced based on AWS documentation. For example, on EC2 VPC, you can check that EC2 VPC can have these return values. So if you call ref against the label like this, ref to that, it will return the VPC ID, the ID of the VPC. So this one, key is VPC, output is VPC ID. Another output is CIDR block, which is the CIDR block of the VPC, and you need to retrieve it using intrinsic function called getAt. So it's already implemented by the change of the template, and you don't have to explicitly write it down in the config, because it will be just spit out by the change of the template. There's the CIDR block, there's the description, the value, which is calling intrinsic function getAt, specifying VPC, which is this one, and the attribute of that, the attribute called CIDR block, and it will produce this output as value, and this is the export for it. So these outputs will be consistently produced by the change of the template as long as you correctly provide the values for the resource creation. And it also produces an output for each resource that you create in the stack. For example, VPC only has this template only has one resource, just the VPC, and each resource will provide 2 outputs. So it's going to have 2 outputs in the output section. But for example, a subnet, this template produces 4 subnets, and each subnet can have several outputs. For example, this one will produce subnet ID, availability zone, so 2 outputs for each subnet. Actually 3 with the VPC ID. Yeah, so 3 outputs for that subnet. That means we're going to see 4 times 3 outputs. That's 12 outputs. Subnet, private A, the subnet ID, the availability zone, and then the VPC ID for private A. Another set of 3 of outputs for private B, subnet ID, value, availability zone, and the VPC ID, and so on and so forth. Why do we need to have these outputs? Because Sceptre relies on these outputs in order to link one stack to another. So, for example, the VPC, we need to reference the VPC ID in order to connect it to subnet, to route table, and internet gateway, and other stuff. So, for example, in the route table, in order to connect the route table to the VPC ID, we use this directive from Sceptre called stack output. So it will look for the stack output of that template. As you can see here, it's print our working directory, and then this directory, and then that template, and then just print out the output called VPC, which should be this one. So it will refer the VPC ID. So why we need to have this? Well, you don't really need to have this. You can also stick with the standard CloudFormation template like this. But in this concept, it will allow you to put more abstractions to your configuration, so you can reuse the same configuration template which was written in Jinja2 format like this, you can just use it again and again and again without modifying these templates. But what you can modify is your configuration file like this. So this one also hard codes the config, the value of the CIDR block like this. And then, which means if going to deploy this to different accounts or deployed multiple times, all the VPCs will have exactly the same CIDR block, which is not good, because probably we want to interconnect all those VPCs, even though probably they will be sitting in different AWS accounts. So we can refactor this and have the definition of CIDR block into a variable file. So in demo02b, which is this one, the CIDR block has been taken out and then defined in the variable file. So this will look for a variable called VPC CIDR block from either provided through command line or provided through a variable file like this. And in order to access those external variables, we need to put that var dot in front of the variable name. Yeah. So we can have different variable file for staging environment, for example. And staging will have 10.253.16.0/20, and production will have different CIDR block. In this case, it's set to 10.252.16.0/20, and then everything else should be the same. So I'm going to deploy the staging of demo02b to a different account. This time it's going to be an account called Harris Demo Staging, which should be this one. At the moment it doesn't have any VPC. And the production will be this one. It's also empty at the moment. Yeah, so let's start. As usual, invoking the script, specifying the account as Harris Demo Staging, try run is false, action is deploy, and then I'm going to invoke that variable file called stagingfiles.yaml, which is this one, and then the item is demo02b, which should be very similar to demo02a, except that the CIDR block is now parameterized, but instead of using the parameters feature of the configuration template, we're going to use the Jinja2 template. So staging should have 10.253.16.0/20. That's staging and demo staging. Yeah, it's correct, 10.253.16.0/20. Now let's wait a bit until demo02b in staging is completed. Then we're going to deploy the same thing to production account, specifying different variable file. So Internet Gateway is created, raw tables are created, subnets are still waiting, network ACL should be there. Yep. Still creating the route entry. Okay, while we wait, I'm going to explain why I prefer to use the Jinja template to produce the YAML file for CloudFormation instead of trying to use the standard CloudFormation format. So the main reason is standard CloudFormation template does not support looping. So for example, if I want to specify multiple tags in this one, I need to either copy and paste, create multiple tags like this, and add another one, say business name, and then another one, call it some code, and again and again and again. Which means if there is a slightly different tag between one environment to another, that means I need to parameterize this, making it like value is referring to some parameter, and I have to go back here, add that parameter here, type equals string, and I don't have to define the default, but yeah, it's very cumbersome, especially when you're dealing with secret groups or network ACL. It's very annoying. It's just not that flexible, and especially when it comes to Boolean operator, checking if, else, something like that, is very annoying with CloudFormation template. But with Jinja 2, we can define that. We can define looping. For example, with that tagging, it was implemented like this. So we'll just loop for a variable on the variable called tags, and then just print out the key value. And then the way you define it is like this. You want another tag, just define the key, another key, business name, some name, some code. There you go. Deploy it. You deploy this, and that resource, that VPC, will have these additional tags. It's as simple as that. So the looping, and also the the logic programming, and the consistency. So since it is also a templating feature, you can produce a template that will consistently produce the same output again and again and again to different environment. For example, the one that I showed you before, the output section of the CloudFormation. This one will be consistently produced by the Jinja template. So let's go back to that deployment of demo 02B. So we have deployed that 02B. Let's inspect the output first. Subnet 02, not this one, this one. Subnet, let's pick private A. It will have now some tags, some additional tags. Pay attention to the building code. It's demo staging 0010. Oh, by the way, I put some source repo URL. This is just my habit to make sure that if I need to find out how I deployed this particular resource, I can find the repo where I put the code for this particular deployment. So this one has this building code set to demo staging 0010. This time let's deploy the same code to production environment. So going to invoke that command again, same script, but this time the account that we need to issue is Harris demo prod. For dry run false, action is deploy. Same, it's different file now. It's prod fast instead of staging fast, and the item is demo02b. So let's check the differences between the staging fast and prod fast. Staging is just environment staging. 50 solid block is that. Production, prod fast has environment production. Solid block is 10.252 instead of 10.253. Okay, let's deploy this. So where this environment is being used is used to map the config for staging and production. So in this case, I have refactored the tags that will be used by the subnets using YAML anchor, and then the anchor is invoked in here using this syntax, star and then pointing to this anchor. And then I'm going to override the name of this one. Well, the original anchor does not have name, so I'm going to introduce name tag, name key in this dictionary. So what it's going to have is this will be invoked by the subnet tag like this. So we'll invoke the subnet tags. Subnet tags is this one, and then this is for public A, so it will look for the section called public A, which is this one, and then it will look for that var environment. So we know that from here environment is set to production, so it will look for production. So subnet tags public A production. So the name will be demo02b public subnet A, and then it will also have additional tags like this: production, SME John Doe, demo production 1010. Let's check the production first. VPC, it should be slightly different. Yeah, it's 10.252.16.0 instead of 10.253. Yeah, that's good. Now let's check the route table. Route tables are there. Internet gateway should be there already. Network ACL. Yeah, they are being created. How about subnets? Okay, subnets are created. Let's see if there is some differences between the tags in here and the tags in staging. So we know that in staging, the building code was set to demo staging 0010. And you can see the building code for production is demo production 1010. Let's go back to subnet, private subnet, tags. Yeah, so it's different string, and it was defined from this config YAML by utilizing YAML anchor and YAML override, and then it will be invoked in the configuration file like this. So this shows that we can consistently use the same template and as the first abstraction layer. We're using that change it to format, and then the second abstraction layer is this configuration file, retrieving different values from the config based on certain values, certain variables. So based on this environment variable, and a variable called environment, if it's going to be deployed to production, it will retrieve the tags from this section where it was designated to, and then it will also invoke the common tags from here, and then it will produce the text as expected like this. So that means, yeah, you can use the same template again and again and again throughout all your deployments. You just need to worry about the values that you need to supply for each environment. And if you want to reconfigure your resources, you can easily do it by defining the configuration here, taking note about what value should go to which environment, refactor them, and then put it either in the variable file in here or in a config file like this, and then make sure that they will be assigned to the correct environment based on certain values that you define somewhere else. Thank you for watching. I hope that explains how I wrote that shared sceptre template. Thank you.